I'm here for another week of looking at all the rocks that I've got. I've actually been able to locate my rock hammer that I thought was lost forever because I got rid of a lot of stuff after my geology degree since I ended up going down a completely different career path. I'm glad that I held on to this, but I will have to get a new pocket knife. And I had a little misadventure this week as well. So it turns out ordering hydrochloric acid is not as straightforward as you would imagine, probably because it's so dangerous. Somehow, though, I managed to order like a 10% HCl, which is hydrochloric acid's like scientific, abbreviation. 10% is extremely dangerous. Don't order anything higher than 1% hydrochloric acid if you're going to attempt to do the same thing. And in fact, don't order it at all if you don't know how to handle it. And if you're very young, make sure that there's an adult with you in the room and that they know the safety precautions of handling an acid, no matter how low concentration it is. Because you never know, you could have an unfortunate accident. No matter how low a concentration is, if it gets in your eyes, you're in trouble. So yeah, I had a whole misadventure where I tried to find a way to get rid of the hydrochloric acid after I got paranoid that it could spill or something like that. Because I don't live by myself, so I wouldn't be the only one in danger. And it turns out not many recycling places take that, so just buy it at your own risk. I will try to get white vinegar instead because white vinegar is actually also useful for running the same sort of test on calcite. For those people who want to check their rocks at home, white vinegar is probably the way to go. That's way safer. But anyways, without further ado and without further rambling, I have some more rocks here. It's actually 11 rocks this time because there are several samples of the same kind of rock, so I just wanted to get them all out of the way. Now, last week I had a hard time actually figuring out what the word is for like mineral that's encased in a smaller rock. That's just a geode. I don't know why I was blanking, but it's just a geode. It's not that complicated to remember. Even people without geology experience know that. So here you go, an amethyst geode. It's pretty cool. Again, same thing. I will just take photos and put them up on screen here. But I hope that's... Yeah, this is just encased in some... Looks like a mafic material rock. I probably should have ID'd the outside as well, but the outside is never as cool as the inside for most geodes, so... Yeah, this is an amethyst geode. I have quite a bit of... I actually don't have that much amethyst, to be fair. I was about to lie to you guys. I don't have that much amethyst. It's my birthstone, but I don't know. I just don't find it as interesting as stuff like... As I was saying, I get interrupted by notifications. I need to remember to take those off before I start filming. What was I saying? Oh, I don't have that much amethyst because I just find more other rocks like more interesting, like quartz. Rose quartz especially is one of my favorites. It's kind of sad that I don't get to call that my own birthstone, but also some of you guys probably don't care about that. For those of you who do, cool, enjoy it. So yeah, amethyst quartz. I think amethyst geode that is. It is a quartz, so now I'm gonna go ahead and move these two to the front of the line because they're way cooler. I mean, because I'm just more interested in talking about them. So these two guys that I'm about to show you are both vesicular rocks, meaning that they have air bubbles, if you remember from, like, I think the first video that I did. But one of them is, like, not necessarily... Because there's so many classifications in igneous rocks. Again, I really do have to do a whole video about that. But there's such a thing called vesicular basalt, and that is actually different from scoria. They're both mafic rocks that have holes in them. Basalt happens to be a larger classification for the mafic rocks that are igneous. They don't have to have holes. In fact, they probably usually don't. Vesicular basalt is just a kind of basalt that has a lot of air bubbles, and it's usually at the surface of a lava flow. And that's where a lot of air bubbles escape from, and that's why they look that way. But anyway, so this is vesicular basalt. It is such a cool... I have a really big sample for... I don't even remember where I got this from, which is a shame, but... I've been collecting these rocks for years, guys. Now, if you guys start going out there and collecting rocks, it might be a good idea to note where you get them from. That way you're not scrambling to figure out where this could have come from like I am. That's vesicular basalt. You notice it's a black color, and this is scoria. It's a much smaller sample. Hopefully it captures the little air bubbles. I feel like the shadows are not helping, and that's because I didn't turn on. Oof, that's way brighter. Hopefully that helps. I have a ring light here, and I'm still trying to figure out how to use it. I don't think I used it in the last video. Yeah, that's way better. If I actually get it into the camera, instead of just, you know. See? Little air bubbles. Now that, we don't need that light all the time. It's way too bright. Although you guys probably prefer the light, but it is what it is. So, the reason that these two rocks are not the same, even though they are similar in dark color and they both have holes, this one is a lot denser. And it's not just because it's a bigger rock. Bigger rocks can actually be pretty light depending on the composition. As you'll find, nature will surprise you. That's all I have to say. This rock is extremely heavy, okay? So that's how you know it's vesicular basalt, and now also another sample of scoria. Because, yeah, it's just denser than scoria. And scoria is extremely light. And don't be fooled. I have held extremely tiny rocks, and they have been very heavy. Okay? If this was vesicular basalt too, this would actually be heavier than this if this was scoria. Just so you guys know. It's really cool stuff. The more you know, as they say. I had a lot of fun in school. I just probably took it for granted as well. So, this guy is also really cool. Okay? So, the host rock for what I'm about to show you, because this is another example of a mineral or gem encrusted in a bigger host rock. The host rock in this case is probably anorthosite. It's just, you know, a mafic rock, another igneous rock. This probably looks fully sedimentary. It is not. This is a fully igneous rock. Yeah, you're going to be surprised how often you find a rock that just looks like anything you can find lying around it. It's actually igneous. So yeah, this is anorthosite. It actually weathers like whitish, yellowish, so that's another clue. Also, the mineral I'm about to talk about very rarely shows up inside sedimentary rocks. That's another clue that even though it looks like a sedimentary host rock, it is not. Usually, if you find this mineral in any host rock that's sedimentary, it's usually way smaller little pieces. So yeah, this guy is so cool. Again, let me turn on the light to help you guys. Look at this little dude. Look at this little guy. That whole dark looking mass in here, that is labradorite. Like, kind of like a Labrador dog, labradorite. That's what it is. I actually found this in New York. My geology class took like a camping trip to Giant Mountain, and we hit several places and mines around there. This was one of the places that I found. This was one of the rocks that I actually found out in nature, along some streams that happened to be apparently known amongst geologists for having labradorite inside the water. Yes, the water was freezing. You do have to do quite a bit of hiking to get to specific spots to be able to find these rocks, so just keep that in mind. Hey, if you're willing to put in the work, you deserve whatever prize you find. So yeah, the dark stuff is labradorite. It's really cool. That's really all I have to say. Apparently, it looks different. Like it shines blue-green depending on the light that's cast on it. I don't know if I'm going to be able to show you that. Yeah, you can kind of see how bluish it looks in that light. Probably better in natural light, as most rocks are. If you ever want to see really cool light stuff, natural light is way better than this ring light type thing. Artificial light just doesn't bring it out as well. This is another sample of the same rock. It's smaller, because I did collect several samples. You never go to a place that you have to work hard to just to collect one sample. That's kind of a waste of time, because you don't know what could happen to the one sample. You could lose it. What are the chances of you losing all your samples, you know? They're not that high. The chances of you losing one, though, are significantly higher. Of course, don't overload your backpack and then have to carry like 2-3 pounds of rocks back down the mountain. Do keep that in mind. What you grab, you will have to bring back down. So just keep that in mind. Now, I'm going to show you a whole bunch of samples of quartz rocks. Because they all look different, so you wouldn't expect them to be the same rock, but they are. Now, these two are probably closest to being pure quartz. And let me actually do that with them. Pure quartz. There you go. Proper bunny ears. Because there's not been weathering, it's not a sedimentary rock yet. This is very close, and if not exactly igneous form of quartz. It looks to me, in my head, I always mistake this version of quartz as calcite, because calcite looks similar. The difference between calcite and quartz, though, if you're ever trying to identify, because they look almost exactly the same to you, if you have the same eye as I do, in other words, you can test it by hardness and by reaction to acid. Quartz has no reactions to acid whatsoever. Calcite fizzes. There's also a little side tangent that I'm going to go on. There's a rock called dolomite that is also going to fizz, but only if you powder it, which means you basically take like a sharp material, you scrape off some of the rock, now it's a powder, and then you throw acid on the powder. If that fizzes, it's dolomite, because it might not fizz in the rock form. So don't necessarily think, oh, this is quartz if you drop acid on it and it doesn't react. You might want to powder it first, and if it doesn't have a reaction, then you can test the hardness. Unless you just want to test the hardness right away, I just like to be very thorough. Now, the hardness test has to do with quartz can scratch steel. And glass, obviously, but the easiest way to test it is with steel, because calcite is not hard enough to scratch steel. I actually did that test with my rock hammer. Typically, you would do that test with like a knife or something, because it's a lot easier. You could also scratch the rock with the knife. Calcite is scratched by steel. Quartz is not, because quartz is the one that scratches the steel. That's kind of, how you tell the difference. Since this is made of steel, though, you can also test it here. You can kind of see the little scratches I made along the surface. That's how you know that something is quartz, if it can even scratch something like that. Because that's like polished steel. So, now, this little guy, raw sample of quartz. Really cool looking. I will also, again, provide photos for everything. Another sample. Looks softer. Is not. There we go. Now, these two upcoming rocks are examples of sedimentary, like, I would say quartz sandstone rocks. Now it's becoming sedimentary. You see the difference between this guy, pure igneous quartz, or I guess, yeah, whatever. Pure mineral quartz, I should say, because it's not an igneous rock necessarily. And this guy, which is a sedimentary quartz. These two are both sedimentary quartzes. You see kind of the difference? That color tends to be typical of like quartz that you find in its raw mineral form. Now this guy is really cool. I hope that the lighting actually helps reflect the little shiny parts of this rock. I'm gonna just turn it a little, see if it does anything. I hate this tiny little camera. Anyway, hopefully I can capture that better. Now see, that is just like an exposed face, like inside, because this rock has been weathered a little bit. But I happened to actually find this on a walk like a couple weeks back. Yeah, sometimes you can find cool shit when you're just walking. I shouldn't curse. Sometimes you can find cool things when you're just walking around. And yeah, this was one of them. This is one of my recent finds. Like the little tiny rock. It doesn't mean that you spend a lot of... Don't spend all your time looking at the ground, because you're going to bump into something or someone might run you over. Obviously, situational awareness is important when you're going, like, spelunking for rocks. But, yeah, so it's really cool. This is an exposed face that's inside the weather, like, that just... The weathered surface, I guess, must have cracked open along that part, so you can actually see the quartz inside, and it's really glittery. It's really cool. And it has a kind of blue color to it, which, can happen with sedimentary quartz. This guy, I have had forever. Okay? I'm not joking. I had this probably since I was a kid. I have no idea where I got it from, so don't even bother asking. I would say probably I also got this in Pennsylvania, because I have been living here since I was a small child. It could also be from Oklahoma, where I used to live before. Who knows? So yeah, it's just a flat. It's a very, very weathered sandstone, though. Like, extremely weathered. It's so round, and it's kind of heavy, obviously, which is normal for quartz. Yeah, it's just really nice. I usually keep this in a little stack of rocks that you might see here. I usually keep this as the bottom of the little stack because I like to stack smooth rocks. I don't know. It's just something about it is very appealing, you know. And then this is the absolute last rock that I'm gonna show you guys today. This did not come from nature. Do not expect to find it just out and about. I did get this from a mine, the Sterling Hill mine in New Jersey, to be exact. At least I think that's where it was, because I've been to quite a few mines during my time as a geology student. So I'm going to show you the rock first, and then I'll yap about it. Minimal yapping at this moment. This is just presentation. This rock kind of did break off one side earlier. Rather, I kind of broke it off because I was intrigued to see what I would see inside. And I actually think that that crack has been there for a while because this is along where it broke. And it looks weathered inside. So I think that, yeah, slowly it's just been chipping off. That's probably why it broke off so easily. So yeah, the black looking minerals in here are zinc iron oxides, probably. It's apparently called franklinite? Something like that. Yeah, franklinite. The white is just calcite. It's very normal calcite. I wish I could actually test the fizz, but I don't have the right material to do, like the right liquid to do that yet, because again, the whole mishap with the 10%, and I'm not about to take that out of its bottle and potentially get serious burns from it if it gets on my skin. So I'm just gonna have to wait till I get white vinegar to make sure that what I think has calcite in my collection actually does. Don't be in a hurry to test something to the point where you put yourself in danger, okay? Just have patience. The white stuff is probably calcite, I'll say. The black stuff is franklinite. And the stuff that looks pink that you would think, oh, that looks like, you know, a feldspar. It looks like potassium feldspar. It's not actually. It's just reddish or brown in color. And it is actually, so it's actually willemite, apparently. I have no idea what that is. I will probably have to do some more research on that. But apparently those three rocks are a common composition of the rocks that you find at this mine. So it makes sense. So yeah, really cool. One last look. Again, I'll provide all the photos as I go on. Well, as I cover every rock, you'll see a photo. Now, that's all the rocks that I have for you guys today. As you can see, I still have quite a few to cover. I am chipping down slowly. I'm probably going to have to start labeling the ones I've already done so I don't redo them. No repeats, don't worry. I'm going to try to avoid that. So apart from that, thank you for being here with me today again. Thank you for looking out at all my cool rocks. I hope you guys are starting to get curious enough to look at any rocks in your collection or to go out and get some. It's really neat. You don't even have to do much walking unless you live like in a city, in which case you might have to go out a little bit because I very much doubt that you're going to find any cool rocks unless there's a little bit of wilderness reserved in the city like a park. So thank you for being here with me today, apart from all that little bit of discussion at the end. If you're curious about anything or just want to get further clarification on something that I mentioned in this video or any of the previous videos, let me know. That may be an interesting video topic for the future. And with nothing else to say, and also being in quite a hurry because I do actually have a busy schedule aside from this, thank you for being here again. And I hope you guys all have a nice day and stay curious.